So today we are learning about LAN and WAN communication in TCP/IP protocol, understanding how data travels across network. So we have two connections, LAN and WAN. So LAN stand for local area network. It covers small area like home, office, college labs. LAN have very high speed connections. LAN uses switch for connecting different devices. The main example or example of LAN is all computer in your classroom connected together. The second one is wide area network. WAN covers large area like cities, countries. WAN has very variable speed. WAN uses router for connecting different devices. The example of WAN is your college LAN connected to YouTube server. TCP/IP protocol have 5 different layers from top to bottom. The first layer is application layer, where user uses the application and interact with system. It has many protocols, but the main protocols are HTTPS, SMTP, DNS, FTP protocol. The second layer from top to bottom is transport layer. It is reliable data transfer layer, and it has many protocols, but the main protocols are TCP and UDP, and the main function of transport layer is segments data at port number. And the third layer from top to bottom is network layer. The main function of network layer is it adds IP address and router packets. The main protocol of network layer is IP address and ICMP and ARP. And the fourth one is data link layer. The main function of data link layer is it add a MAC address to your data and detects error and try to solve that error. Data link layer has a many protocol, but the main protocols are Ethernet and MAC. And the last one is a physical layer. Physical layer has many protocols like cables and Wi-Fi and signals. It has a function to convert data to bit and signals. Here the data flow, how data is flowing from sending side. The data is flowing from top to bottom, and while receiving the data is flowing towards bottom to top. So here is the example of how data is transferring from PCA to PCB. So as you can see, application layer, the user types the data like hello. In second layer, transport layer, it adds a TCP header and a port. As you can see in a screen, TCP and hello. So it's as a TCP header to the data. In third layer, network layer, it add a IP address to data. As you can see, it has IP address, HTTP and hello. The fourth layer is data link layer. It adds a MAC address to our data. As you can see here, MAC address, IP address, TCP and hello. At the last physical layer, it converts a signal into bits, binary numbers. So here at PCB, this one is from PCB. So from physical link layer to data link layer to network layer to transport layer, and finally the receiver receives the message hello. So the key technical concepts in TCP/IP protocol, the first one is IP addressing. Every device need a unique address to communicate. Like every device has its own IP address. So IPv4, this is a format of IPv4. It has 32-bit address. Packets and frames. Data is broken into small chunks for transmission. While transmitting data from sender to receiver, the data is broken into multiple pieces, and at a receiver end it will combine and give a address. So as you can see here, packets equals to IP header plus data, frame equals to MAC header plus packet, small chunk equals to chunk transfer, And the third main key concept is routing. How data finds its path across router uses IP address, chooses best path forward, connect different networks, works at a different layer. So router helps to connect one server to another server, so it will find the shortest path, so we can take less time to transfer data from sender to receiver. And the fourth key concept is switching. How data moves within a local network. Switch uses MAC address, forward data within LAN much faster than router, works at a data link layer. So switch works more faster than router, so it is more efficient than router. So in TCP/IP protocol, while transferring data from sender to receiver, we may have errors, so we need to solve them. So TCP/IP reliability mechanism. So first, acknowledgement, like senders sends the data to receiver, so receiver sends a acknowledgement to senders, like he received the data. If he did not receive the data, so he will send the acknowledgement like he didn't receive the full proper data, like sender sends 5-bit data and receiver received only 2-bit data, so the 3-bit data is lost. So in acknowledgement, receiver sends he only get 2 bits of data. So here we detected the data, and then we start the process of retransmission. So sender again sends the data to receiver, like in WhatsApp we may send data to someone, but due to network connection the data may not fully sends to receiver, so we again send the same data, like same retransmission process. So here this step by step, senders sends packet. Each packet has a sequence number, so each packet assign a sequence number, like priority. The first packet is going first, second, third. Receivers get first, second, so receiver gets first and third, but second is lost, missing sequence number defect. So here the second bit is lost. Receiver sends the negative acknowledgement, so sender retransmit packet to receiver, gets all packet correctly. So finally at the end, receiver sends the full acknowledgement that he received all 3 bits. So key features of this detection and error process. So we assign a sequence number like priority, which data has a more priority, and checksum detects corrupted data. So for detecting purpose we are using checksum algorithm to find the which data is lost. Timeout handle lost acknowledgement, and flow control prevent review overflow. So here real life analogy, like how data is transmitted. So network communication in application layer creates the data and message, transport layer breaking into segments, network layer adding destination address, data link layer adding tracking info, physical layer physical transmission, sending a parcel, writing the letter. It is similar, like both are comparing, like sending a parcel and network communication. So here in sending a parcel, writing the letter, your message content, packing in box, breaking into pieces, writing address, sender and receiver address, courier tracking, internal routing information, and then at last delivery truck. So basically it is comparing with how network is transmitted, and comparing to how we are to send a parcel. So here a main simulation, live packet movement simulation. So here we can see like how PC1 is sending data to PC2 using all 5 TCP/IP layers using switch and router. So here you can see the data is received, like PC1 sended a message hello to PC2. Here you can see PC2 received the data. So here advanced simulation, like full structure. So this is the main one, like how data is transmitted from PC1 to PC2. So here you can see the data is received. So here is everyday application, smartphone. Every app uses TCP/IP to communicate. Online games, real-time multiplayer require fast networking. Like we are playing PUBG, so it is also using TCP/IP protocol. Cloud service, Netflix, Spotify, Google Drive, remote works, video calls, VPNs, emails, smart home, IoT devices communicating via network, healthcare, medical devices, and record needs secure connection. The internet, billions of devices using TCP/IP protocol.